Welcome to AWS DevOps Locust Tech YouTube channel. So welcome to Kubernetes classes, Kubernetes series. And last class we have seen about difference between Docker and Kubernetes and Docker and container ID. So Docker, what are the different two features we have, and container ID, what are the commands and we have seen, and what is CRI we have seen. So now today we are going to discuss about the brief complete complete architecture of Kube API and individual features. Okay, let me check this. Let me share my screen. Can you see my screen?
Yes, sir.
So we in the Kubernetes architecture. So there are so a lot of components you see. So maybe API server, scheduler, controller manager, ETC, and proxy, kubeproxy, and kubelet. So these are all features you have seen. So last class, whatever I have explained everything scenario of entire architecture of Kubernetes. So there we have explained everything in one go. When in the sense when one call, I mean one class, right? So now I would like to walk you through individual concepts of Kubernetes in the cluster. Okay. So API server, scheduler, manager, ETCD, controller, and kubelet, kubeproxy. Okay. So I would like to walk you through. So I will take you up along with this all individual components. Okay, so we'll talk about API server first. Okay, what is API server? So last class also I have explained, but I'm not sure the how much you have grabbed. So again we are going to discuss about this, because once if you enter into the Kubernetes, you never get chance talk about theory. Okay, that's where you have to learn very quick, and you have to learn very depth here itself. You have to understand the concept of Kubernetes. Understood? So that's the reason. So I have made individual uh, slides for each individual component. All right. So let's talk about Kube API server. What is Kube API server? Okay. So first of all, what is Kube API server? So Kube API server is a primary component of Kubernetes. Okay. So when you run kubectl command, the kubectl utility is in fact reaching Kube API server first. Understood? All right. So my intention, you need to understand proper. That's it. Okay. Is it visible?
Yes, sir.
Okay. So Kube API server is responsible for authenticating, validating, request. Okay. Authenticating and validating request, and requesting, updating data in ETCD in the form of key value store. In fact, Kube API server is only component that interacts directly to the etcd data store. This is the only one component which is directly interact with the right etcd. Okay, so the other components such as kube scheduler, okay, kube controller, okay, and manager, kube control manager, and kubelet and kubeproxy. Okay, so API servers to update in the cluster in their respective areas, right? So you don't need to use kubectl command line. Okay, for example, when the Kubernetes API server first authenticate the first, okay, then validate it, and then it retrieves the data from the etc cluster. Okay, first it will reach to here. Okay, it will directly contact here. Okay, it will check whether it is any other data is there or not. It will take the data. Okay, and from etcd cluster, then and it respond back. Actually etcd cluster will definitely respond back, okay, with the requested information. So you don't need to use any kubectl command. Okay, instead of that you could invoke enter API directly. Okay, and sending post request. Okay, so uh, for example, this is architecture like a cluster. Okay, master node, for suppose this is master node, this is worker node, this is worker node, this is master node. Okay, so in this kube API server will be there, right? So kube controller, okay, and etcd, all right. So kube scheduler, these components are there, right? So first uh, first first person will reach to kube API server. Kube API server first will reach to here etcd. Okay, so it will check. Okay, first request authentication, first go to the kube API, and it will check and it will validate. In this case API server creates pod. Okay, so whenever request comes, API server will create the pod object. Okay, without signing into a node. Okay, without signing into node, so directly Kubernetes will create one pod object. So update information in the cdi server, sorry etcd server here. So it will create one pod, it will update in the etcd server. Okay, to the user. Okay, update to the user, and that pod has been created, right? Some so and so pod created, and it will keep in the information. Then the scheduler continuously monitor. So after that, what scheduler do is here, this is the connection, right? Okay, scheduler continuously monitor the pods, right? So it will monitor API server, not pods, first API server, and it realizes that yeah, there is a new pod with no new node assigned, right? As can you understand or not? First of all, we have a components. In these components, whenever we get request from user, so that Kubernetes, what it will do is it will create a pod object. Okay, that will assign to that will store in etcd. Then kube scheduler, what it will do, yeah, I got something, some pod. Okay, okay, that's fine. So now what I have to do is, let me check first. Okay, so yeah, one empty pod is there, that I have to something I have to assign, which means it is scheduling, it is trying to plan. Okay, so then also Kubernetes sorry kube schedule will always continuously monitor API server. It will keep an eye on this, okay, whether new pods are getting or not. It is continuously will be in connection with the kube API. Okay, the scheduler definitely will identifies the right node. Okay, kube kube scheduler will identifies the right node to place the new pod on and communicates back, which means like it will always try to give right node. Okay, it identifies the right node to place new pod on and communicate back to the Kube API server. First it will check, okay, it will give so a pod, then it will check checking and continuously it will monitor, it will check, then it will give the response back. And API server then updates information in the ETCD cluster. Okay, then after we got, okay, I scheduled, so yeah, there is a place you have, you can place that new pod, so and so somewhere there is a space, we can keep this pod here. So this information it will be update to the Kube API. What Kube API will Kube API, what API server will do is this will store the information in ETCD. Okay, ETCD, this is a cluster. Okay, API server then pass that information to the kubelet. Where kubelet here comes into the picture? Here the kubelet. This is the kubelet. What is the use of kubelet? It will give the takes the instructions. It is a command line, right? The kubelet then it creates the pod, right? You can give the instruction here itself, you can give the pod. Okay, the kubelet it creates a pod on the node and instruct the container runtime to deploy application image. Once done, the kubelet updates the states back to the API server, which means like this. Okay, it will connect like this. Understood? Here, this connection. Okay, so and API server will update again the data. Oh yeah, one new pod is coming. Again, this data will okay, that information it will take and it will store in ETDs. Everything, whatever information it will get, API will go and it will store ETDs, ETCD. Sorry. So a similar pattern definitely follow for all the nodes. Okay. So Kube API server is a center of all the functions. You understood? It is interacting with the user. It is interacting with the kubectl. It is interacting with the ETCD. It is interacting with the kube scheduler. Also, it is connected with the controller. You understood? Which means you can understand them now. So Kube API server is like centralized center for the different tasks that needed to be performed to make a change in the cluster. Okay, understood?
Yes, sir. Yes, sir.
So this is what Kube API server will do. It does, right? So this is very important. This is the first important component, primary component in the master node. Okay, in cluster. Anyways, all right. This is all about Kube API server. Let's see the installation. How does, okay, what is the process for installation? See this. Installing API, first you have to install the API, Kube API server. If you are bootstrapping Kube API server using kubedium tool, okay, you understood? This is a kubedium tool. So you have to bootstrapping Kube API server using kubedium tool. Then you don't need to know this. But if you are setting up using hardware, then Kube API server is available binary in the Kubernetes release page. Okay, so first, so you have to use kubedium tool. That's it. Okay, this is the command. For example, if you want to download Kube API server so and so version 1.130 binary, so Kube API server, this link goes to there. Okay, so this is the command. Okay, I have taken from there itself. So wget to so and so. This command if you use, you will get kubedium. So API server will be installed in your Kubernetes. You understood? That's it. Alright, after
Yes,
installing,
sir.
if you want to see kubectl get pods, yeah, you can see master, okay, kube system. If you want to see the kube system, kube ADM, after installing a kube ADM, it displays. If you want to see, you can see like this. Okay. So Kube API server, view the Kube API server options. Okay, cat etc Kubernetes. This is the directory path. Okay, you can see the options. Okay, in the pod, like where it is located here, Kube API server dot YAML. So this is the location. If some, whenever it's your whenever it's needy, so if you want to go the location, okay, API server location, if you want to do modification, changes, troubleshooting, whatever, first you have to know, right? So this is the location. Cat, for cat means if you want to read etc Kubernetes manifest and kube API server. This is the file path. So you can go there, you can see what is the kube API server .yaml file. For better understanding, if you go and check, you can understand entire YAML file, how Kubernetes kube API server is running. Okay, for knowledge purpose also you can go and check. Right, that's it. Okay, and now this is finished, right? And here, so
Sir, before installing a Kube API server, we should install Kubernetes in Linux, sir.
Kubernetes in Linux. So what container
Or
container D is there, right? Container D CRI, that
yes,
is
sir,
for
yes, sir.
only. So Docker prerequisites I
Okay.
told already. Docker I said,
Yes,
container
sir.
D I said, nerd control I said, and CRI I said. Whatever your choose, your wish. If you want to choose it, anyone, you can choose anyone. First of all, you have to install that. On top of that, you have to install this. That's why I'm
Okay, sir.
going
Okay.
sequence one by one. Go one by one. I'm
Okay, okay,
going.
sir. Okay.
Okay. So
Okay,
first,
sir.
first you have a. I'll give you here. First you have a base mission. Means your laptop. Maybe on top of this you are using AWS. Okay, in this AWS you are using EC2, which means Ubuntu. On top of this you have to run CRI or Docker something. On top of this you can run these commands like kubeadm, whatever you want components. So you will work on this environment. Understood?
Yes, sir.
Right? All right. Then next. So yeah, if you want to see these commands, you have to use. Okay, we'll see. This is not theory. I am not closing with only theory. We'll go install and everything will do. All right. Next, kube controller manager. What is manager? What is kube controller manager? Okay, where is that? Yeah, here. Kube controller manager. Here you can see. I'll go ahead there itself. This looks nice for me. I think so. Yeah, it looks good. That's fine. Yeah, what is kube controller? Controller name itself indicates it's controlling. What it is controlling? Entire structure. Okay,
Entire
entire
structure. Yes, sir.
entire structure, entire system. Okay, what your mind is doing, it is controlling your entire body, entire function. It is controlling entire function. As we discussed last class when Kubernetes architecture, we have already seen kube controller. Okay, how managed it is. Okay, various controls in we have seen different controls. Okay, a controller is a like office. We have seen in that Kubernetes some ship. Okay, in that ship there is offices also, different offices. I told suitable example. So have you remember last class? Okay, a control is like an office
Yes, sir.
or a department, something like a electrician department, a welding department, or
Yes, sir. Yes, sir.
some shipping, logistics, any electric mechanical department, something like that. So there are offices, okay, in the ship. So um, they have different offices. They have their own responsibilities, right? such as officers for ships would be responsible for monitoring and taking some necessary actions about related to ships and what functions. Okay, so whenever new ships arrives, okay, or it leaves, or so some already one ship is there, it has taken containers and it has to leave, or some ship is coming. Okay, so these are all functions, all right. It has to place somewhere. Okay, after that you have to load this. These are all functions. Okay, so these office, all the management, entire things, these are all management. Okay, driver doesn't know, this captain doesn't know what to do next. The captain can operate only the ship, small ship. Okay, but these functions, whatever management things will do by control. Okay, so they can take care entire containers and damaged, or any fuel related issues, or so something like this. So maybe if it is suitable or not, this example try to understand. Okay, continuously on lookout, watch, they have to status, they have to look what are the next ships are coming, what are the going, all the data they have to maintain, they have to control all the things, take care the necessary actions to immediate. Okay, situations. Okay, in Kubernetes also you can opt this example. In this Kubernetes, in Kubernetes terms, controller is a process that continuously monitor. This controller is a process. Hey, do you remember 8085 microprocessor?
Yes, sir.
So what it will do? It will functions. Okay, this
Functions.
microprocessor containing the code, instructions. Okay, according to
Yes,
our
sir.
requirement, we will design the 8085 microprocessor. This what it will do is, whatever instructions we have given, whatever code we have dumped in this, so it will operates integrated circuits, you can see. Okay, so something like that. So this is also type of that. Okay, it's a kind of brain. Okay, IC is a brain for motherboard, you know. Have you heard this?
Yes, sir. Microcontrollers. Yes, sir.
Yeah. All right. So controller is a process that continuously monitor the state of various components within the system. It is responsible for this, it is responsible for this, it is responsible for this, it will be responsible for all. It will manage all the components. Okay, and it's bringing whole system into the desired function state, proper functioning state, which means it's a kind of brain. Understood? So this is very general terminology, you can to understand what is the controller. That's it. Okay, fine. It's okay. Let me take this here. Okay, are you feeling bored with yellow color?
No, sir. No, sir. It's fine.
Yeah, so node controller, there is node controller. In controller there are lot of controls are there. Node controller, job controller, okay, cron controller, so a lot of, okay, something out of which node controller is there. We'll see all one by one. Okay, so for example, uh, in ship we have seen, for example, this is one office. uh, okay, so it is kind of controller. In Kubernetes it is node controller. What node controller will be responsible? It is responsible for the nodes. It will take care the nodes. For example, this is one node, this is two second node, this is third node, this is fourth node. Okay, what is node? Node in the sense it contains entire containers and all. This is node in the sense it's not pod. There are a lot of components inside. For example, master node, worker node. Okay, so for example, this is one node, this is one node, this is one node. For example, this is node 1, node 2, node 3, node 4. Okay, so containers we have in this. Okay, pods, different pods we have, right? So what it will do is, it will Kube API will be mediator in between these two, right? Node controller and all. So the node controller test the status of the nodes every 5 seconds. What node controller will do is, it will test status of the nodes in every 5 minutes. Node control is responsible for nodes. It will continuously monitor. Okay, it will continuously monitor. It will checks every 5 minutes whether this node is available or not. Is there any crash issue? Is it really reaching or not? Something like this. Continuously it will monitoring like this. For suppose there is some disconnection or network issue or some IP issue, some any internal issue, it is not able to reach this node controller. What will happen is, so after making it unreachable, it gives 5 minutes to come back. It will check after 5 minutes. If it does not, if doesn't remove, okay, it doesn't remove the pod assigned to that node, and it provisions them on the healthy ones if pod is port replica set. For example, if it is not available, what it will do is, it will wait for some time. Okay, it will replace by using replica set. Within some time, given time, it will recreate. That is the purpose of replica set. Okay, so here where it comes, replication controller. So like this, lot of controllers are involved inside controllers. Okay, the next control is replication controller. Okay, it is a responsible for monitoring the status of replica sets and ensuring that the desired number of pods are available at all the times within the time or not within the set. If pod dies, it create another file, another. That's why I don't write anything. I want it back. Yeah, this, for example, this pod die, it will create again. You understood? That is the reason Kubernetes is very much famous. Understood? For example,
Yes.
there is a one application inside of this container, so it is continuously running. Okay, but some different issue, pod got crashed. Again, within seconds, fraction of seconds, the same pod it will create by using replica set. That is the reason Kubernetes is very famous, right? Where we are using Netflix, Hotstar, YouTube, all using Kubernetes process. Understood? So now these were just two examples of controllers, like a node controller or replication controller. So there are a lot of controllers. I can try to write here because it is having very small enough space. Deployment controller. Second one is namespace controller. Next, endpoint controller. Okay. Next, job, cron job. That's why while I'm teaching Linux, cron job in Linux, I told emphasized we'll use cron job many times. Okay. And node controller, we have seen that. Okay. Next to replication controller. So there are many controllers are there, but don't worry about this two, how we have to install and all. Once you set up with the controller, main controller, it automatically come up with this controller. So this is a big kind of logic brain behind the Kubernetes. You understood? So this is very interesting, right? So
Yes.
so how do you see controllers? How do you see controllers? Where are they located in your cluster? How? This is a question now, right? So all the packaged in a single process known as Kubernetes controller manager, which means whatever which I have shown now, all will be included in this controller. That is a logic. Okay, that logic already predefined in this controllers. Okay, when you install Kubernetes controllers or Kubernetes controller manager, okay, the different controllers get installed as well along with this controllers. Isn't it? Is it clear?
Yes, sir.
Okay, how do we install and view Kubernetes controller manager? Let's see. Give me 1 second. See, right? See, I told you, right? I have draw something somewhere on white blackboard. See this? If it is for suppose if it is a node controller, this node controller is inside the controller manager. This is controller manager, kube controller manager. Inside the kube controller manager, node controller is a one part. This node controller will be is with the kube API server. Okay, and it is kube API is contact with the pod one. Sorry, node one, node two, node 3. For example, node 3 is not reachable to this. What it will happen is again replica set will come into the picture. It will create itself, which means that is called as auto heal. Okay, it is healing itself. So that we have to set. We'll see it later. But for better understanding, you can understand replica set will do. It will create again the same node. Understood? Whatever pod is there, that pod is, if this pod is not reachable to the controller, so replica set will create again. So the same pod with the same applications with the specifications also will same, but IDs will be changed. Okay, so I hope you understood. No need to read this abbreviation, right? You understood?
Yes, sir. Yes, sir.
Okay, so what is node controller also I have shown. So how to see node controller, kubectl get to nodes. So you will get worker node 1, worker node 2, worker node 3, 4, 5, 6, whenever whatever nodes you have, it will display like this. Understood? Next, I have explained all these things. See, cube controller manager we can install by using this. Okay, so version so and so version. So by using this command. Okay, so these are all commands. If you want to see a cube controller manager, okay, you can go this location, etc systemd system kube controller manager dot service. Okay, you can find this file. All right, so kube controller manager have different commands. Okay, this is for control manager kubeadm. See this, it deploys kube control manager as a pod kube system namespace. This command for namespace -n you have to use. Okay, kube controller manager by using kubeadm to see these options within the kube location. This. Okay, okay, this is for kube controller manager manual. So this is non kubeadm setup. You can inspect options by viewing kube controller manager service. Okay, you can also see the running process effective option by listing the process on master node is searching kube controller manager. Okay, it is not required now, but whenever it is required we can use these commands. Understood? So that's all, that's it about kube controller manager. If you have a doubt, you can ask me now itself.
No, sir. No doubt, sir.
You understood, right? I'm trying to reach you.
Yeah, yeah. Yes, sir. Yes, I understand.
Yeah, so next topic is kube scheduler. Okay, kube scheduler. Okay, you see this? Can you please let me know what you understood about scheduler for the last two classes?
It schedules the tasks for the container, sir. Like which container, what it schedules, sir, basically.
Okay,
Yeah,
so
pods.
which means scheduler means it will schedule and it will plan, and which container is open, which container has available, and which pod, whatever pod is getting by using kubelet, so that pod where I have to place. Okay, it will plan.
Yes, sir.
Okay, simply in general
Yes, sir.
terms. Okay, so let me try to go there slide. Better I need to use this slide for all. This is useful slide. Yep. All right. So next topic is kube scheduler. All right. So Kubernetes kube scheduler is container scheduler. It's not a job scheduler. Okay. So that is the definition he has given. So the function of kube scheduler is to dispatch newly created pod. You understood? This one is important.
Yes, sir.
The function of kube scheduler is to dispatch the newly created pod to the most suitable worker node. And in this process, kube scheduler will monitor all the worker nodes inside the cluster, and it select most ideal worker node according to the filtering and scoring policies set by use. You understood? For suppose, for suppose there is one container. I don't use this here. Clumsy. I will go back to here. For suppose this is one container. This is one container. This container capacity is, for example, 10 CPU core. Okay, I have um, one node, node 2, node 3, node 4, node 5, and node 6. So for this one CPU core, this is two CPU core, this is four CPU core, this is six CPU core, and this is 8 CPU core, and this is 12 CPU core. Okay, yeah, here in this example, for suppose these, I have a container, this is one, other container is, okay, um, 8 CPU or something like yep, um, 2 CPU for suppose, and this is other container, um, 12 CPU core. So I have three containers, right? One, two, three. Now scheduler came into the picture. Now someone trying to create a pod, right? That pod, where pod is ready now. Okay, pod has been created by user. This pod I need to place somewhere. Okay, so how many nodes are there? I have node 1, node 2, node 3, node 4, node 5, node 6. Okay, fine. And also it should be fit for CPU core as well. Okay. What scheduler will do is, now scheduler come to picture. It will check the containers first. It will check the nodes, right? So what it will do is, it will fit a container here, 10 CPU here. Okay. In this pod, it will place the pod here because it is suitable. Okay, because here it is available 10 CPU. For example, I have a 3, that's okay, I can also compare with the others. Okay, okay, but this is actually 2 CPU core, but it is capable for 10 CPU. hmm? So something like this, it will come and check with the containers, it will come and check with the nodes, and what it will check with the availability. Okay, and it will accommodate the new container with the available container and nodes. I hope you understood. Okay, some might be something, some may be missing, but concept is the same. You understood? You can I need your response.
Yes.
Yeah, Ashwant. Yeah.
Yeah, yeah. Yes, sir.
So for suppose here, if you can see this, for example, this is CPU 10 CPU core. How many here? 4, 8, 8, 12, 16 is there. Okay. What scheduler will do is, scheduler will check container. Okay. And for example, this 8 is suitable, right? Here, this anyone is
Yes, sir.
suitable. So it will keep here. So it won't keep 12 because it is exceeding. Okay, this is
Yes,
also
sir.
it will check here. Oh, okay, this is 12. It doesn't support. Yeah, this is 16 one. It is doesn't support. Yeah, this 2 is fine. But one only I have to pick. Okay, let's check the health. Okay, which one is available? So yes, this is good. Let me check this. Okay, this is also not available because it is 4. Okay, best, it will check the best. Okay, so you can understand from here itself because it is important. The function of kube scheduler is dispatch new created pod to the most suitable worker node. Most suitable worker node. In the process of kube scheduler will monitor all the worker nodes, all these worker nodes. Okay, first it will check and it will monitor. Okay, it will decide itself. Okay, this is suitable. I have to push. I have to fit this into so it's a CPU and select most ideal worker or worker node according to the filtering and scoring policies set by use. According to that, it will do that. Scheduler will do that. Scheduler work is like that, assigning the task. Okay, that is what about scheduler. Come down and so this is how you have to install the scheduler. See this? Try to understand here. Kube scheduler manual. This download kube scheduler binary from Kubernetes release page. Example, so this is version 1 1.13 run. So I'm not sure whether it is works or not. Let me check. I will check whenever I install. Okay, so this is the command for that to release so and so this version. Understood?
Yes, sir.
So this we have to use
Yes,
for
sir.
the kube scheduler. So these are all packages we will all install at a time, but individually we are discussing for the better understanding. You understood?
Yeah. Yes, sir. Yes, sir.
So next, so whenever you install kube scheduler, so these are all you can observe. You can set up kubeadm tool. Kubeadm tool display the kube scheduler as pod in kube system namespace on master node. Kubectl get pods. This is a command. If you use this command, you will get pods. Understood? Kube system pod. So if you see, this is the place where you can find the scheduler file. Okay, that's all. So these commands we are going to use soon, right? Next,
Yes.
next we are talking about kubelet. Okay, what is kubelet? What you understood about last class kubelet? Hmm?
Like it is the command. Like it uses commands, sir.
Hmm. Kubelet is for instructing the, it
Commanding,
will follow the
instructing, yes, sir.
instructions, okay,
By the
by
user.
user.
Yes, sir.
Okay, all right. So this is where kubelet is placed. This place has given here in worker node. Kubelet is
Yes, sir.
placed in worker
Every
node.
worker knows.
Yeah. So you can come here, see this. So kubelet is the sole point of contact for Kubernetes cluster. Okay, this is the point of contact. If you want to talk to the API server, scheduler, control manager, etc., kubelet is main point of contact. The kubelet will create the pods on nodes. Scheduler only decide which pods goes where. This is the statement very much clear. This is very small one, but it gives more
Yes, sir.
information. Kubelet will create the
Yes, sir.
pods. Kubelet itself create the pods, but scheduler will place where it has to go, where I have to place. For example, for example, so by using kubelet, I have created a pod. This is pod. I have created one pod is ready. So now what scheduler will do is this scheduler, this is scheduler will go and come and check. Okay, okay, fine, there is a one ship. Okay, this is also one ship. Okay, there is a container here, container is there, one container is there, and another one is big container. Okay, so we'll check. Okay, the size is fine, it suits like this. Okay, this will come and place here, which means it will only see the place. For example, in general scenarios, so if bus comes in the bus stand, we'll go fast. Okay, we will find the place, right? So we are like a schedulers. So this, for example, if I want to try to this container here, is it fit? Is it will fit? See, it is exceeded, right?
No, sir.
So it is not fit for
Excellent, yes,
this.
sir.
And this pod is suitable for this place. So scheduler
Yes,
is
sir.
responsible for keeping the a pod in particular place. That's it.
Pods.
Okay.
Yes, sir.
And kubelet is responsible for creating the pod
Creating the pod.
because it
Yes,
is
sir.
command line 100%, right? So that is the difference between schedule and kubelet. So this is installation steps. So this is where this is a command. Okay, so we need to download the binary. Okay, download kubelet binary from the Kubernetes. Okay, so and so, oh, same kubelet 1.13 version should not be changed, guys. Version should be same for all, otherwise it will be conflict, you will get error, it won't works. It will show success while you are installing. Separate kubelet, kubectl, kubeadm, API, controller, everything that package while you are installing. If you use different sources for each individual, so it won't works. You have to take one, you have to find one source, and you need to identify it, you need to find the one best source, and you have to install entire one package from one source itself. Hope you understood. All right, so you have to take these binaries and you have to extract it and run the service. All right, so next view kubelet options. How? By using args command. So you can see kubelet. All right, that is what about kubelet. Next, what is about kube proxy? So what do you understood about kube proxy?
It's used for communication, sir, between two pods or containers,
Yes,
like two worker nodes. Yes, sir.
correct, exactly. That's good. Anyways, I'm very happy to hear that. Okay, so at least you understood my class. Anyways, okay,
Yeah, sir, it's
yeah.
understandable.
Kubeproxy. We have to understood somewhat about this definition. Kubeproxy is an implementation of network proxy and a load balance that serves a as a link of this each node with the API server. It runs in each node of your cluster and allows you to connect pods from the inside or outside of the cluster. Okay. So kubeproxy, where it will be? It will be in worker node, right? Right. So kubeproxy
Yes,
will
sir.
be
Yes,
in
sir.
worker node. So this kubeproxy, what it will do, it is always try to reach the nodes. Okay. So it will create a network in between two nodes. Okay. Or pods. Okay. So it
Yes,
will
sir.
try to balance. Okay. So this is for network connection. This is network related kubeproxy. Always it will connect each other. Okay. So that is the purpose of kubeproxy. And if you can see here, we have discussed about this, right, in last class. So there is some web application and other database application. This is on top of some one container. Okay, these two different containers in different places, not talking each other. How we have to do this by using pod network, which is called as kubeproxy, right? So it has connected with the kubeproxies, right? So that then only whenever network connection will be established, after that web application and database will application will talk each other, right? It has some kind of service DB. So there is some IPs, it will create IPs. Okay, these IPs IP tools we'll see later. Okay, so the installation, if
Yes,
you
sir.
see, so these are all IP tables. By using IP tables, it will create the IPs for pods and containers. Okay, so
Yes,
this
sir.
is installation steps. Kubeproxy. Kubeproxy.
Yes, sir.
This is download package. This is binaries. So you'll get this by using this. You can download. So what is the version? So it's a version. So if you after that extract it and run it, after that you can see like this. Okay. So if you use this command kubectl get pods hyphen n and cube system. If you use this, n means number. Okay, so if you want to see the numbers, so you can see, you can get like this, it will looks like this, you understood? So for better understanding, I
Yes,
really
sir.
need much hard work, guys. Please do more hard work on
Yes,
this.
sir.
We have to be gems, we have to be more expertise in this Kubernetes. This is very 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 excellent and beautiful tool, so where we don't have any other tool like this. Understood? This is a king of now,
Yes, sir.
king of deployment orchestration. Okay, so that's all about
Yes, sir.
components of Kubernetes architecture individually. We have seen each and individual component in the architecture of Kubernetes. So we have seen, we have summarized that. So yes, we have seen about API server. And what is API server? API server is the interaction between the user and all the components, like for example ETCD. Okay, so
It is
yeah,
ready. Yes, sir.
ETCD, whatever the information will get, it will create one pod. Okay, so by using kubelet. Okay, so that that will store in ETCD. It will take the information, give the information. That is what will do Kube API server. It is a kind of mediator, if you can understand. Okay, so then Kube scheduler. What scheduler will do? Scheduler always monitor the Kube API server. Why? Because someone trying to reach or someone trying to create by using kubelet, one pod is ready. Yes, it will give the information to the this will give information to the etcd will store the information. Then scheduler, what it will do is it will monitor and it will keep the that whatever available pod in the container. Okay, somewhere. So and after that, cube controller, what controller? It is a brain. Okay, this controller is contact with all. Okay, this will be responsible and it is contact with the communicate with components, and it is a kind of brain, it will controls everything. Okay, and next etcd. What is etcd?
Scheduler.
Etcd is a
Yes, sir.
storage, it will store in the form of key value. So uh, did we discussed anything about etcd? No, right? We have not discussed TCD. I remember. Just now I remember. I hope. I think so.
You have shown the slides, sir.
Did I? Did we discussed ETCD, right?
Yes, sir.
Okay. So yeah, maybe I'm not sure, but I will discuss it again. So ETCD, what is ETCD? I remember some we did not discussed. I think so. I feel okay. Anyways, we'll talk about ETCD now. ETCD is a distributed related reliable key value store in Kubernetes. It's secure and fast. So yes, we have discussed ETCD in last class, not now. Okay.
Yes, sir.
ETCD is stored in the form of key value store. It is a key and it is a value. Sorry, it is a key and it is a value. It will store like this. Okay. Whatever the information it will get, so ETCD will store in like this in that ETCD, right? So next slide, more about ETCD. See this. So like this it will store. So key value store. The key value store information in key value format. So key is name and value is some so and so H1. Okay. Age. This is a key and value is 45. H1 23 or 24. Okay. Location. Yeah, it is a key value and it is Bangalore. Okay. Salary. Yeah, it is a key and it is $5,000. Okay, something like this. So this it will store like this key and value store, then only it can understand properly, right? So if you want to control the
Yes,
ETCD
sir.
or if you want to customize the ETCD, so you can give like this. Why I'm telling all this means if Kubernetes itself it will create itself ETCD, but by default it will be there. But if you want to do customize, you have to know how we have to give the values to the ETCD. Custom we can also do the customization ETCD. That is the reason I'm telling. Okay. So
Yes,
maybe
sir.
why it is why I have skipped I don't know. Maybe directly I have gone through. Okay. So that's all about ETCD. I hope you understood. So
Yes, sir.
that is how this architecture works. I have taken class for architecture around 2 or 3 classes, right? For better understanding.
Yes, sir.
Deep dive. We have to deep dive into this architecture, then concept will clearly understand to your subconscious mind. Understood? So if you can see this worker node, so this is kubeproxy, this is container id, whatever. By the way, you have to install this container id into this here and here. Okay, all and kubelet, you have kubelets, you have pods. Where pods? Yeah, this is the question. Where pods can store? It will store in worker nodes. Okay,
Worker
different
node.
different
Yes, sir.
pods you can store in worker node. But in one container, how many pods we can able to keep? One container, how many pods? One pod is best practice. Okay. So if you keep 2 pod, this is called as side container pod. Sidecar. Sidecar pod or helping pod. For networking purpose, for networking help we'll use basically this is the best practice if you use one pod in one container. Understood? We should if you keep like
Yes,
this
sir.
many pods, for example I'm telling this is one node, there is one application nginx, this is apache, this is java. I kept three different applications in one worker node, right? First, suppose there is some issue with this node. What happened continuously without any hesitation, without uh, any notice, without any notice,
Yes, sir.
this nginx will collapse, apache will collapse, java will collapse. We
Java
will
also.
lose
Yes, sir.
three different applications or it will be down. For example, if it is down, entire three applications will down. So we can keep two containers, that's not a big deal, but we can keep, but this is not a good practice at all. Understood? I can prefer only one pod
One
in
pod.
one container. If you use other pod, second pod, that will be called, that we can call it as sidecar container in one pod, sorry, pods in containers. Okay, anyways, okay, and that one helper, okay, helping purpose. Understood? Yeah, this is all about the
Yes, sir.
architecture and components of Kubernetes. Okay, that's all about this, and we'll see in next class. Uh, maybe we will try to install Kubernetes container, maybe container D or Rocket or or Creo or anything. So let me check whether which one is good one. So we'll try to install and we'll do the
Yes,
setup
sir.
on our system. All right.
Okay,
Okay,
sir.
that's all about today's class about Kubernetes components. We'll see in next class. Until then, take care. Bye bye. If possible, today I will take other class. Is it fine?
Okay, sir.
All right. Thank you,
Okay, sir.
Ashwin.
Time, sir.
Sorry.
What may be the time? What may be the time,
I
sir?
will inform you, Ashwin. Okay.
Okay, okay, sir. Okay.
So let me check once, and after that we will because I did not prepared any this slides. Okay, I need to find out the source first. I have to find out the source,
Okay, sir.
or
Okay.
else we can use the same source
Okay,
whatever
sir.
I have mentioned in the slides in this class. Let me try first
Yeah,
of
yes,
all.
sir. Yes,
So
sir.
then after I will let you know. So we'll join. So this is Saturday, right? We have enough
Okay, sir.
time. Okay, Saturday we
Yeah.
have to utilize
Yes, sir. Yes, sir.
more time because time is very much precious. So we have enough time in Saturdays and Sundays. So we'll cover more in this Saturdays and Sundays. Okay. Okay, all the way.
Yes, sir.
Okay, you do practice continuously. Do not let you leave this architecture. After this class also, don't waste your time. After this class also, you have to go individual components. You have to read yourself and you have to make a notebook for you. That's why I'm not sharing with you. Because if I share with you, okay, you will relax. You will sit aside and you will be relaxed. I
Yes,
know.
sir.
That's why
Yeah.
I'm not sharing anything. You have to do by your own.
Yeah.
You have to create your own. You have to write your own. You have to practice your own. Okay, don't depend on my documents. I don't want to share my documents.
Yes, sir.
This is not good practice at all. Okay,
Yes, sir.
you have to do more hard work. All right,
Okay, sir.
wish you all the best. Good luck, buddy. Next
Yes, sir.
we'll see you in next class. Until then, take care.
Yeah,
Bye
thank
bye.
you, sir. Yeah, thank you.